All right, so second day, I tried to put some different stuff on than what we did yesterday of, some topics that I think that you guys will see. One thing, I think you'll see one question on a trig graph. So kind of making sure you guys know what the A, the B, and the C all represent in an equation if you had to write one. I think that's like something I think that will show up. Make sure though, whenever you guys are asked to write an equation, what do you need to have? Y equals. Okay, don't forget that little part. And a lot of times when you guys are asked to write your own from, no multiple choice, they'll give you one to model. So they're telling you guys that this is a cosine curve, right? Let's go through some things. What does the A represent?
Well, where it is in the y-axis, right?
Yeah.
No, it's going to be 4.
No.
Amplitude.
Amplitude. Good. A is the amplitude. Right, and what that means is that you cut the graph down the middle, it's the height up and the height down from the middle, right? So if we split this down the middle, okay, let's be careful. See how it's only going down 2 and up 4? Yeah. Okay, so where would the middle be?
The 1.
The 1, good job. Right, so we cut that at 1. Right, now what's the height up and the height down?
3.
3. 3 units between 4 and 1, and then 1 and -2. Right, so my amplitude here has to be 3. Okay, now they tell you it's a cosine curve, so we're going to do cosine. Now the D, what's that word represent? That's the frequency. Good. Okay. And this is a tough one. Does anybody know what frequency shows?
How many full cycles?
Full curves between what though?
0.
Yes, DOV, good job. All right. The frequency is how many full curves you see between 0 and 2 pi. So it's a little tricky because a lot of times what they do on your picture is they don't show you 2 pi. You have to kind of get an idea of what would happen if you went to 2 pi. So cosine curves kind of look like horseshoes. So here's one full curve. That only goes to pi. So if you went to 2 pi, if you doubled it, how many curves would you see? 2. Good. So this is going to be 2x. Right. What does the C represent?
The shift.
The shift. Good. The shift up, down, left, right. What do you think? If it's a plus C at the end.
Left. Right. Up.
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 Okay. If it's at the end, that, and any kind of parentheses, it's up or down. If it's within parentheses, that's the horizontal. That's like your left and right. So since it's positive, right, it's some kind of shift up. So this is going to go up how many units? How many units did this thing start? Like, think about where you split it. How much was it pushed up?
3.
Not 3. Good one. Ashley, good job. Yeah. This is going to be shifted up 1 unit. Because you didn't see how it was like, it wasn't, not that it started at 0, but usually your graph is the same amount up as it is down. You know what I mean? It's like balanced on both sides. This time it wasn't. So you guys had to figure out how much it was moved up or down. It was moved up 1 unit to start. That's why when we drew a little line down the middle, right, it was up 1. So at the end, you end up plus 1. And these kind of questions, I don't know what you guys will see. They might ask you something easy, like what's the period of the trig graph. They might ask you what's the amplitude. They might ask you an equation.
The period just
Yep, yeah, let's actually do it. So I did ask you guys, oh, this is a good thing too, okay? Watch out for like little mistakes like this. I did this all right, but I would have gotten a point off. Does anybody know why?
You have to state the values.
Right. Make sure you don't forget little things like this. They ask you once, they want you to state A, B, and C and write the equation. So I need to say A was equal to 3, B was equal to 2, and C was equal to 1. Right. They'll take off points for little things like that. So just make sure you guys read the questions very careful. If they did ask us something about finding the period of this, ask me what's the period formula. Good, 2 pi over b, and then we would have to do 2 pi over 2, reduce it, and it would just be, the period would be pi. Which makes sense if we look at our picture, because The period shows you guys the length of time it takes to see one full curve. So if we look to see one full curve, we saw it in just pi, which is the period. So that's kind of like everything in a nutshell about a trig graph. I don't know what they'll ask you guys about, to make things possible. All right, this is something that's been coming up quite a bit. When they give you guys something in radians and they want you to go to the nearest minute, this isn't the same question you guys just had, but it's one like it. So I've seen this come up over and over, and the idea, the starting idea is important. Okay, so you're going from radians and we want to go into minutes. What do you have to get into first before you can go to minutes? Degrees. Good. Okay. So notice we have 3.45 radians, and we want to go into degrees. So what do we multiply by? You got it. 180 over pi. Right. This question, make sure. See how when you guys have the 3.5 radians, you don't have a pi here? Right? Because our pi wasn't in the big problem, so don't put a pi there. Right? Now, when you guys do your multiplying, 3.45 times 180 divided by, now make sure you use your pi key, right? Divided by pi. Now, this is what it is in degrees. What do we use to get into minutes?
DMS.
DMS, yes, we gotta go second app, choice 4, DMS. And they wanted you guys to round, here, minutes.
198.
Alright, so here, this is your degrees, careful with this part. This is your minute, right? This is your seconds. Okay. No, you don't want to write the whole thing. So when you guys, if you're having issues with rounding, seconds, you have to think about it like in terms of 60 seconds, right? So if this was 30 or more, you would make your minute go up. If it's less than 30, it stays the same. So this is going to be 197 degrees, 40 minutes.
Oh, so you do it.
Oh yeah, that's sorry. I thought you meant this part too. No, just the minute part with the degrees. Sorry. 197.40. Do you guys remember doing that one in your last region? Yeah. Something similar, yeah. Right? They like this kind of stuff where they give you guys radians, but not with the pi, where you actually have to use your pi key to do your conversion. So I think you'll get something like that, right? Another one's pretty popular. Good. No, hopefully not. All right, I love what Ashlyn was saying. When you guys see this, anytime we see the sine, cosine, tangent of two angles being added or subtracted, where do we need to look? Reference table, okay? So we want the cosine of x minus y. So the first thing I need to do is go to my reference table. Find that cos x minus y or a minus b formula. Okay, so cos A minus B, here we go, this one right there. So cos A, cos B, plus sine A, sine B.
Are you going to use like triangles?
Yeah, good job. Now, if you guys would rather, instead of the A's and the B's, I would replace them like X's and Y's, because that's what we're dealing with. So instead of your A, I'm going to put in an X, and instead of the B, I'm going to put a Y in. So cos X, cos Y. There we go. All right, so before I start drawing my triangle, I want to figure out what I know and what I need to find. So sine X. So when I see a sine X, they give it to us, I'm going to put in 12 over 13 in its spot. And make sure you guys are just taking the number, not the sign anymore. And the cosine of Y, I know it's this. So this part is going to be 3 over 5. All right, I'm missing some stuff though. And notice, what does acute angles mean? What quadrant do you have to be in acute? 1, because less than 90 is acute, so quadrant 1. All right. If we know something about the sine of x, I want to find the cosine of x. Mariah, what do we need to draw?
You draw a triangle.
Perfect. Good. All right, so I'm going to draw an X triangle. Now I'm in quadrant 1 because it's at acute. So the sine is the opposite over the hypotenuse. So when I do my labeling, opposite, hypotenuse, how do we find the bottom one?
Square.
Good. Nice. Or, what is this one?
12.
Yeah, it's a 5, 12, 13 triangle. You're right. Okay, so if you could use Pythagorean theorem, or you could just know that it's 5. Now, what's your cosine going to be?
12 over 5. No, 5 over 13.
Good, 5 over 13, adjacent over hypotenuse. So put 5 over 13 in. Great. Okay, so now I have all the X stuff done. I have to figure out the Y part here. So let's draw another little triangle here. Different stuff. Here's my Y triangle. Okay, so we know cosine of Y is 3 over 5. So imagine adjacent over the hypotenuse. You got to build a triangle. Very good. Nice. Pick up, there's a packet right next to COB. And that's the one on the right side. Yep, that one. If you want the one we did yesterday, it's on the other side, but you can see it. Okay. So what would this one be? 4. Great. Okay. Now we want the sign. I'm going to fill this part in. If you want to think about in SOHCAHTOA, what's the sign in?
4 over 5.
You got it, Kayla. Good job. 4 over 5. The opposite over hypotenuse. Perfect. Okay, so let's go ahead. Once you guys have this all out, you're just kind of doing it out. If you want to use a calculator, if you feel more comfortable with that, feel free. Do the multiplication first, though, before we do any addition. Okay, so 5 times 3. 15 over 65. Plus 12 times 4 is going to give us 48 over 65. Should we add them up? Okay, make sure if you guys are using fractions, you put them in parentheses with a lot of your operations. Oh, there's one there. I feel like that's kind of struggle. Usually, like with these multiple choice ones, actually, what did you guys get as your final answer when you added?
63 something.
63 over 65?
Yeah.
Great, okay. Usually they like, when it's like 5, 12, 13s or 3, 4, 5s, they like to do those as multiple choice because it's a little faster to get the other side. So I think this come out kind of a lot, so it's like we're drawing a triangle to figure out other side. Okay, I know some of you guys wanted some stuff from back in the beginning of the year, so.
Yes, yeah.
Let's see what we got to do here. Close. Conjugate, yes. Good, nice summary. All right. So we start this out with our normal one. The radical on the bottom is not good, but you have 2 terms in the bottom. So to get rid of it, you have to multiply by the conjugate. Super. Now with the conjugate, what's the only thing that changes? Middle. Good. Only the middle sign. So we're going to do the top and the bottom by 3 plus radicals. In the bottom, yeah. But in the top, what do you have to do? Good job. All right, so go ahead and distribute that through. All right, you're right. In the bottom, we just have to do first and last because they're conjugates. What do we get? 7 times 2. Bring that 7 through.
He texted me looking more into this, and I said, "My turn." And then he said, "Why are you so early?" If you listen to this video section, what? If you listen to this video section now.
We got 21 plus 7 radical 2 on the top. On the bottom, when you guys do your first 9, that's minus 2. Good. Is that okay with you guys? Radical 2 times radical 2 is just 2.
You read the wrong one. You read the one for yesterday.
Alright, please watch out with anything, especially if they say simplest form that we always reduce. So if we draw a little heart around all the numbers, what goes into 7, 21, and 7? 7. Good job. So 7 goes into 21 3 times. 7 goes into 7 once, and this is also a 1. So your final answer should be 3 plus radical 2. We don't have to break the 1. Hopefully this is just 3, right? Just 3. Good. How's that one for you guys? We haven't done it in a while, but you know, I think if they're going to try to make it like an easier exam, they'll put like some of these kind of questions in.
I wish the whole exam was that.
Me too. You guys are good at them. All right. Oh, Covenant, perfect. Look at this one. All right. So, I thought completing the square was one that we haven't done in a while. And this kind of covers like all the ways they could kind of ask anything about it. So, I thought this one was like the hardest way too. So, if they say something about completing a square, you have to use completing a square. Like, they won't take if you try to solve this using like quadratic formula. Okay.
If you were in a complete square, then only you get the complete square.
If you like, but you don't use completing the square? I don't think so. I think they say like in a problem, a method like other than completing the square. I mean, if you got it completely right, you might get maybe. It'll usually tells us pretty specific, like in the grade, which is what we kind of can't do. All right. So with completing the square. All right. When you guys write everything out, what does your leading coefficient have to be? This is the hardest way they'd ever ask you.
1.
1. Good. Okay. So what would you have to divide this by to get 1? Good. By 2. So we first thing you want to divide everything by 2.
Anthony said he'll be here. He read the wrong one. Okay, so whenever it's completing the square, it always has to be 1 to the...
And then, yep, and then usually what I see for you guys, like everything that's come up on the Regents so far has been 1. So
you don't just take the 2 out each.
I mean, you can do that, but you don't want the 2 to be there at all.
Okay, so we'll get rid of 2.
Okay, so now when we do our completing the square, anybody know the first step? Good, nice job. Subtract that 2. Perfect. So you always want to bring the constant over. Good. Now, you guys made a little bubble. What goes in our bubble? Half of the middle term, so minus 3. Good. Now, when you do your minus 3 in here, what do we have to add to the other side? Negative 3 squared. Good job. So if we square this, 9. So 9 is going to be added over. Now, what is over here? 7. Super. Okay. So I want to just cover another way to do completing the square, which you guys I think saw in the last one. This class may teach you different. She teach you a little bit different. Completing the square. Okay. So now the other way to do completing the square, right? We make our little bubbles for it. We kind of skip some steps. The other way you guys could see this. Move this around. Okay. Is let me go back to my original. Okay, still starting with the minus 2x. Now, what they do is they put these little blanks in. All right. So, what is half of negative 6?
3.
Negative 3, and you square it, we get 9. So what they do is they add 9 to both parts, which, if you guys look at this part over here, we still get our 7. How would you guys factor this, though? Double bubble. What are your factors of 9 that make a 6? 3 and 3. Negative. Good. What does this mean? X minus 3 times x minus 3, what's it the same as? As it squared, right? So see how these two things are the exact same thing? Yeah. Well, I don't like that. Well, just, I don't know, some people teach it different ways, so I just want to make sure in case God is different way. Yeah, I mean, whatever. It's literally the same exact thing. We just skip like this extra step. So let's go back to this one now. Okay, how do you guys get rid of something squared? Square root it. Good. Watch out when you guys start taking the square root of things. What do I need in front? Plus or minus. Super. Okay. So cancel those out. Remember, radical gets rid of something squared. So we have x minus 3 equals plus or minus radical 7. Okay, what's my last step to get x alone? Add the 3 over 3. So it should be x equals 3 plus or minus radical 7.
Why is it a plus and minus?
Anytime you take the square root of something, you want to use plus or minus because, Kayla, when you think about a radical being formed with a square root, do you know if I had like radical 9, let's say, was this formed, is that 9 made by positive 3 times positive 3 or negative 3 times negative 3? You don't know, right? So by putting this plus or minus, it takes into account that it could be either one. How's that? We're just kind of remember the steps a little bit. This class make sure you just explain. That's how the algebra, like the new Common Core algebra is a lot like showing that stuff. So that's probably, but it means the same thing. So if you guys like it this way, it's totally fine. Same process. Okay. These next two, I put 2 on because I want you guys to practice one after I show them to you. These can come up as part 2s or multiple choice. They're pretty common. People always forget how to do them out. So let me do the first one with you guys, and then I'll have you guys do the second one. So it's asking you guys what the solution set is, and you have a quadratic inequality. Do you see any absolute value signs? No, so you don't do your 2 cases here. If you want to show some work, which we can do, is try to factor it. Do we have factors of 28 that make it 3?
8, 4. No, wow.
7 and 4. Good. So there you go. Next. 7 and 4. Which one's going to need the minus? The minus 7 plus 4. Super. Okay. Now, notice we have an inequality, not an equal sign. So if you did have an equal sign, when you guys set these to 0, we would have x with a 7 and x with a negative 4. But here's the issue. We don't know which way our inequality signs face. So one way we did this was making a test point and it stinks. We got to test it out with like all these intervals. Or we can use our graphing calculator, which is way, way easier. So let's use our graphing calculator and kind of figure out which way our inequality signs should face. Okay, so we're going to go to our y equals piece. Okay, and we're going to type in the quadratic equation, but we need to put in our inequality sign. So x squared minus 3x minus 28. Okay, so we have to get the less than or equal to sign. So we're going to do second math, and then pull up the one that looks like your paper, so it's choice 4. And then put your 0 in. And now if we graph this, oops, right, for some reason, if you guys were doing something, your graph looks weird, go to the Zoom 6. They'll always get you back to normal. So what this should show us is the points that the special ones that we had. We had something with a 7 and a negative 4. So on my calculator, here's your 7, here's your negative 4. With the inequality, is the value going to be less than negative 4 or bigger? Less than. Good. Okay, so let's go to my over here. So I have less than negative 4. All right, let's look at it with the x with the 7. That's going to be bigger than 7 or smaller?
Bigger.
Bigger. Good. Okay. So x is getting chomped into 7. No, we're not done. If this was a part 2 and you left it like this, we're getting a point off. Anybody know why?
Yes, you didn't write
Or, yes. Oh my gosh, you guys are getting good with that.
What
Right?
happens if it was a disjunction though? Would you write
That is a disjunction.
conjunction?
Conjunction is going to like go together. Hopefully that's the next one.
Oh yeah, okay.
So just make sure you guys do your or is going the opposite way. Put the or in, and then we're good to go. Alright, why don't you guys try this next one? Anybody need help putting it into your calculator and the button? Second last, and this time it was less than 0. Ooh, alright, so it looks different right than the last one. When you guys got all your numbers, you got a 3, the -5. This is a conjunction or disjunction? Conjunction, good. So the way you write it is very, very important. Okay? If you have trouble with your inequality signs, right, if you organize your numbers all together, so think about which number is smaller. You had -5, right? And then we had 3. X is going to go in the middle. They're always going to be facing toward the right, like the chomper, because when you look at your number line, are these numbers bigger than -5 or smaller? Bigger, good. So when you go to your inequality, the x needs to get chomped because it's bigger than the -5. But is x going to be smaller than 3 or bigger than 3? Smaller. So x is not going to get chomped with the 3. Well, yeah, because think about if you set this to 0, what would happen? Yeah, yeah. But you could get that too once you graph it, like you could see where the numbers are. This is kind of just nice to show your work if you need to a little bit. Okay. Do you guys, are you okay with putting that on the calculator? I think you'll get one of those as like a part 1. Let's see, here's another good one. Alright, so we have a complex fraction. Any ideas where we need to start this? Common denominators, good job. Okay, make sure you get common denominators in one single fraction first before we're doing all of our copy, change, flips. This kind of gave us some issues in the last one. So get your common denominator in the top and get one in the bottom. So what do you want to multiply the first fraction by? X. Good job. Remember what you do to the bottom, we have to do it to the top too. So x times 1 is x. And we have our plus 1 all over 3x. And once you guys do that common denominator, make sure you push them together. On the bottom, what does our first fraction need? 3, good. Right, what's the second one need? X, perfect. Okay, good. So now we have 3 times 1 is 3, plus 1 times x is x over 3x. You want all one single fraction. So, yeah, that's great. Good. Once you're here, now we can do the copy, change, flip. X plus 1 over 3x times, what's the bottom? cancel, good. So we should have x plus 1 over 3 plus x. How's that one for you guys? A lot of you flying through it early.
And you can't cancel out those two x's because like they're
They're married by addition. Yep, good question, Kayla. Yeah, anything that's grouped by addition or subtraction, we can't cancel parts of them. They're married.
Did your mom
Not, I don't know if we did the same one, but we did one very similar to it. I can't remember if you guys did that. There's one kind of similar to the last one. I skipped one? Oh no.
That's the one I was pointing out.
Oh geez, I didn't even see it up there. Sorry guys.
It's showing.
Okay. Thanks so much. Alright, sorry. We've had a lot of these questions that have been kind of like already organized for you. But a fraction over another fraction. Do you guys already have single fractions formed? Like is this already one thing and this already one thing? Yeah, it's not separated like the one we just did. So if you guys already have it in a nice form, go right to your copy, change, flip. Copy our first one. 36 minus x squared over 6 all squared times. Alright, make sure you remember to flip that bottom fraction.
Don't you have to reduce everything?
Yes, by reducing we mean like factoring, right? Not going cancel crazy here. Okay, so make sure we factor everything possible. I see a lot of issues come up with this kind of stuff. When you guys factor difference of perfect squares, because 36 is a perfect square, so is x squared. If the numbers first, when you do your factoring, what's got to go first?
The number.
The number, good. So this is 6 plus x. Got it, nice. Perfect. Okay. This is a little bit tricky. When you saw something squared, and Kayla, you knew this, how many times has that been happening? Twice. So write it out. This means x plus 6 times x plus 6. What do you guys think of that one? Double bubble. Good.
Okay.
X and x, good. 3 and 6. Great. Which one is the plus? Which one's the minus? 6 is the plus. Good. 3 is the minus. Super. All right. So once everything's factored, now you guys can start going cancel crazy. Get them all done.
Or should they wear? They're all like, just like, yeah.
Well, that's what I was thinking, but I don't want them to be underdressed or overdressed. Okay. Yeah, that's what I told them, and then I'll have a dress shirt. Yeah, because we're all wearing nice dresses. Yeah, so I told them either a polo or a dress shirt. I don't know if they had to, like Kurt said they wore like dress shirts and ties before, so I don't know if they had to do that. Yeah. Yeah, yeah, exactly. Yeah. No, yeah, exactly. Alright, thank you. And I tried reading my book for reading tomorrow, because I keep forgetting that.
It is all for it. No, thank you. You're welcome, Kaylee. I'll see you tomorrow. I'll be early.
Buddy, were you late?
Okay, so when you guys did all your canceling, let's see, this is gone. Do you have to leave a -1 when there's a plus in the reverse? It's commutative, good. So we don't leave the -1 when it's reversed in addition, only if it was subtraction. These can go. X minus 3 can go. Did you guys just get 6 minus x? Yeah, nice. Okay, good job.
Can you put it over 1?
If you put it over 1, it's not wrong, but like, they won't take points off for it.
Alright.
But if it's multiple choice.
Because I did at first and then I realized.
She peeked in and then peeked out. Alright, this kid, someone was working on a problem like this, we just haven't done them in a while. Could be a part 3, I think. A little bit different. What do you think?
You have to get common denominators.
Common denominators, good, okay, good. Now, this is a little different than the last one we've been doing, because the other has an equal sign, right? The other stuff didn't have an equal sign. So, what we want to do is get a common denominator across the entire bottom, the whole thing. Okay. I'll let you guys think about this, this is tricky.
I got it. We have to do that weird thing, because it's +2, we have to do.
I think you got it. What does this one mean?
You have to link
X. Can I just multiply this one by 2?
No.
No, okay, what is
X plus 2.
perfect, yes, guys, good job. Right, and then the 1 means both of them, it means both things. This one's going to be an X and an X plus 2. Make sure what you guys do to the bottom, we do it to the top too.
Why is the first one do that?
See how this one's got an X? Okay, now if you try to make these the same, you can only do it by multiplication. So if you took this and you times it by a +2, what does it become? Is that the same thing? No, so the only, I always think if you guys get in trouble making common denominators, what one has, the other one needs. So you can kind of like flip flop them, and it always will work. Okay, because this is an equation, what could you do with the bottom? Cross them all out, good job. Get rid of the whole bottom, okay? Only when there's an equal sign you can do that. Okay, now we're going to stop the top with a normal equation. So x times 4x, so what would you guys get there?
4x squared.
Good job. Oh, I love this question. Tricky part right here. Okay, do you have a positive 12 or a negative 12 you're distributing? Good. So make sure you take that negative with it. Okay, you have to distribute a negative 12 through. So negative 12 times x is going to be negative 12x. Negative 12 times 2. Good job, guys. Alright, so now on the other side, well, we have a 1. Is 1 times this going to make anything? No. So let's just take our x squared. X squared plus 2x. Okay, now how do we solve it?
You gotta set it equal to 0.
Set it to 0. Awesome. And keep that 4x squared positive, so let's bring the right side over. Good one. Okay, this will totally be like a part 3 for you guys. A lot of work in here.
Grouping.
All right, grouping. Yeah, I don't think there's a GCF, right? Nothing that goes into 3, 14, and 24. Get those at grouping. So 3 times negative 24. What's that going to give us?
Negative
72. Good. All right, this is tough. So, you know, things that multiply to negative 72 but can make a negative 14 when you add or subtract them.
4 and 18.
4 and 18. Okay. She's got it. So let's see. If we try this. We try 72 divided by 4. 4 and 18 definitely work. And when you subtract them, you could get 14. Perfect. Yeah. Good job. That's good. Those are some hard factors. So 4 and 18. Now just make sure, which one do you need to be the negative if you want a negative 14? So there's 18. Good job. And this is going to be a plus. Super. Okay, so let's rewrite this. 3x squared. Which one's got more in common with these 3? 18, yeah. So I would do a minus 18x, then the plus 4x, just so it's easier for you guys to factor. Okay. So you're taking the middle out and you're putting these two things in its spot. Right? And then we have a minus 24. Okay. Alright. So we have now 4 terms. Anybody know what the next step is? No. Yeah, good job. Split it down the middle. So we want to take the GCF out of each part. So the GCF here is going to be a 3a. Okay, and then we make our own little bubble. X minus 6. Good. Remember, bubbles should be the same. So careful though. What's the GCF on the other side? Plus 4. Good job. And then we take that out. We get an X minus 6. Okay. All right. Join our 2 little GCFs together. So 3x plus 4. And then we write our bubble common binomial 1 time. Alright, your last step, what do you have to set all these equals to? 0. Good job. So 3x plus 4 equals 0. Right, minus 4. Did you guys get negative 4/3 and 6?
Yeah.
Okay, now your last thing you have to check with these rational equations, what can you not have in the bottom of a fraction? What's bad if you had it in the bottom?
It's undefined.
Okay, all right, you have the right word, Brittany. 0. If you have 0 in the bottom, it's undefined. So the last thing you want to do is make sure that if I put in like 6 in the bottom, will you get a 0 at all?
No.
No, 6 plus 2 is 8, that's a 6, that's good. If I put in negative 4/3, will this make 0 at all? In the bottom? No, you're good. What about if you got a negative 2 as an answer?
Yeah.
Yeah, then it would be bad and we don't want to take it. You would reject it. This is just a place where they might try to trick you guys with like not checking, but you at least got this far, good amount of points. All right, let's go to this one. You stayed yesterday, we did one of these, and I thought it was a good one.
Was this like later?
Yeah, when everyone peaced out.
Oh, you got it. I don't know. I did
I think you guys will see one of these too.
Oh, yeah, this is y equals k over x.
Yes, good. Y equals k over x. Perfect. All right, good. Well, Brittany, what was your keyword in here that knew your
Varies inversely.
Good job. Varies inversely, inversely proportional, inversely variated. Okay, we want to use y equals k over x. That's your general formula. Now this one though says d varies inversely as t. So how do you want to rewrite your formula?
D equals k over t.
Perfect, Katie. I always kind of just go in order. Usually it reads the same. Okay, so do your d first, and then the d. All right. Now your first step when you guys do this is your goal is to always find k first. So in your equation, there's got to be some kind of value that you could substitute in. So if d is 20,
40.
and k is going to stay k, t is 2. How do we find k? Ooh, you got it.
This is on that review thing.
Was it the same one? Or a different one?
Yeah, it was in the review book.
The same one?
Yeah, it was the one I did last time.
Yeah, wait, did you do January 13th or something?
The last
So 40 equals k?
one.
Now, you're not done. They want you to find t when d is negative 5. So you're going to go back to your equation again. All right, sub everything in. So negative 5 is d, k is 40. We don't know what t is. Okay.
Same problem.
So now, cross multiply again. So 40 equals negative 5t.
And you just divide by -5.
Great. So what's your final answer?
Good.
Negative 8. Awesome. Okay. These show up a lot. I mean, I think on almost every region you have some kind of inverse variation problem. Is that easy for you guys? Hard? Easy? Good. Good. Half the battle was like seeing it and like recognizing the formula. So that was good, you guys. Get off like that. Okay, so logs keep coming up as like an issue for you guys. So I put 2 questions that I thought were kind of tough. Can't do it with this one because you have to understand the log and know about it. So this would be one. I think you guys could get this. Could be a 6-pointer on your exam if they want to do something with logs, or at least a 4-point question. You're trying to find x. Anybody know the first step?
Well, there's logs on one side, but I can pass it.
Okay, good. So that's great that you noticed that, Ann. There's 2 ways you guys could see these problems. One, when there's logs only on one side. One, when there's logs on both sides. So you start them the same, but they kind of end differently. So your goal, if you guys are ever asked to find x, is to get single logs by using your log property. So I want to make this into one log. So I'll start with our log, the little 3, x plus 4. Now what does the plus sign mean? Anybody have an idea? Multiplication, good. So we're going to multiply by what's next. No log in that little base though, because good, just the x minus 2. By using those log rules, we only write the log one time. Now, if you guys had a single log on each side, you can cancel them out. Here we don't though. So you guys are good at these problems. This whole thing is together. You can't solve logs when you're trying to find x if it's in log form. What do you have to change this to? Good, nice job, Sophia. Base points are exponent, we gotta use they. So the base, this huge part's the answer, this little 3 is the exponent. Alright, why don't you guys think you can rewrite this? Okay, so when you guys do all this out, 3 cubed is going to give us 27. Yep, what should you do over here? Boil it out. Great. Okay. You want to combine some like terms. Because you guys are solving for x, make sure you get it equal to 0, so we're at a minus 27. X squared plus 2x minus 35. What would you guys use the factor? 5 and 7. Nice. Good job. So x and x, 5 and 7. Which one needs the plus? 7. Okay. Alright, last step, split these things to 0. So we get x equals 5, x equals a negative 7. Now again, there's these little places that they're going to try to trick people. What could you not take the log of? A negative or what else? 0. Nice, Anthony. Good job. So let's just check out. If I put 5 in here, so if I put a 5 in, will you guys get 5 plus 4? That's 9. 5 minus 2? 3. That's good. All right, we can't get negatives or zeros, so that's fine. 5 works.
7 doesn't.
Ooh, yeah, if you put negative 7 in, negative 7 plus 4 is negative 3. We can't do that. Okay, so can't do it. Okay, this one does not work. Now, you guys weren't sure. Do you remember your little, like, on your calculator, you had some shortcut tricks? If we went to the alpha window key, see that log base, choice 5? Okay. If you tried to put 3 in and then maybe like negative 3, and you want to see what that equals, see how it says error, non-real answer? It's because you can't take the log of a negative number.
Wait, how'd you find out that it was alpha window? Because when I told you.
Oh, you could do math.
Yeah, because when I told you it was math.
Yeah, and there's a lot of little shortcuts. If you do, like, well, math has everything except error down. Alpha window and alpha y equals. Right, those are like alpha windows. This one, you get your absolute value, your sigma. You guys won't use any of this stuff. That's for calculus. And then choice 5 is that. If you go alpha y equals, this is how you can write it in fractions. So like, see how it comes up as a fraction? You can just like say anything. Does anyone's calculator in here not have the log base? Check, especially if you're borrowing one. Does yours have log base? Check it out.
How do I check? No, I was just on that.
No, she's got it.
She's got it? Okay. Anybody else borrowing one that does not have it?
The older one?
The older ones don't. So on the test, you might want to like use all. If you need to do this, Mariah, at all, just take another one. Alright.
Can you just show one more time, because I don't see something like that.
Yeah. Here, use mine just so you can practice on it. Okay, so go to alpha window. You should get a little screen that pops up. Okay, so go down choice 5 where it says log base. Now if you try to take, like, I don't know, you could do anything. I just did the one that we would have had up there. I mean, negative 7 you could put in. So you get error?
Yeah.
Okay, so it just kind of shows you if you're not sure, you can try it out. It doesn't work. zero or negative.
Okay.
Okay. You're welcome. Sounds great. Keep it in case you need to do anything on there. All right. Someone asked me this question yesterday too. I thought this was a good one. Brittany, good job. All right. So you're trying to solve this for t. All right. T's in the exponent. And there's 100. Now I love what Brittany was saying because as soon as you see an e, if you're trying to solve for something, what do you probably need to use? ln. Yep. Good job. Now before you take the ln though, what you need to do is get the base alone. What's the exponent connected with? The a, the e, or both?
Just the E.
Just the e. Okay, so your first step, we need to get that alone. What should you do first? Good. Funny. That's the e. Good job. So e 0.035. That equals 20? Good job. Alright, so now once the base is alone, we separate and get rid of that e. We're going to take the ln of each side. If you guys can't remember where the what the relationship is, on the same button in the calculator. So what happens when we take the ln of e, you're really applying like the law of rules. So, yep, those go away. And if you had an exponent, where did that move to? In the front. Good. So really what this is going is moving to the front, 0.035t. Those are going away because the ln e is just 1. Cancels out. Alright, so now we just need to solve this. So on our calculators, the ln button is on the left side. The ln and the e are kind of the same button. Just a second, some of them. So it might remind you, the ln is 20. Okay, figure that out. So 2.9, that was equal to 0.035. See, in the last step, just divide by that 0.035. So we want to nearest hundredths right here. Okay, so it's 2 decimal spots, so we should get 85.5. That was good. You guys remembered that a lot of stuff with the ln means. That's fantastic. How did that go for you? Not bad. Okay. Good job. Great. That's quick stuff there. All right. And this last page, I wanted to do one of these yesterday. Actually, did I put 2 of them on? All right. Yeah, that works good. Okay. This is a lot of good practice. But I didn't find a question. So here's the first one here. So in this equation, and they give you a little number, they're saying the number of snowboarders in millions is X. Oh, sorry, Y represents the number of snowboarders in millions. And X is the number of years since 1988. Find the year in which the number of snowboarders will be 10 million for the first time. Okay. All right. So how are we going to start this thing? Anybody have an idea? Read it again. There's a lot of stuff going on. So take a second. We need to try to figure out what's what in here. Yeah. Awesome. Good job. Nice sentence. So the number of snowboarders in millions is the Y. Now just be careful here. See how they say 10 million? It's already in millions. So what do you just have to put in for the Y? 10. Good. They're looking for you guys to find the number of years that we're going to be reaching this 10 million. Now, when you guys have an x in the exponent, this is a little tricky. We can get the bases the same, or we have to use something. Does anybody know? You guys done this for a long time. I think it could show up. No reciprocal. No reciprocal. Okay. So you want to use log to find it. If you can't get it, because think about it this way. If you try to get the base alone, what this x is connected with, it's only with that 1.21, right? Only group with that. So if we divide by 0.5 to get your base by itself, you're going to get 20. So 20 equals 1.21 to the x. Now, one way you guys see this is to get the bases to both be the same. But is there any way you can make something to like the something to be 1.21? Any ideas? I don't think so. There's no way we could do 1.21 to something to get 20. So you can't make the bases the same. You have to use log to solve it. And it's very similar actually to the last one you guys just did. Right? If we take the log of each side, we have our log of 20, right, and the log of 1.21. Where would the x go? In the front, because you're applying log. Right, now your goal is to find x. So how do we separate these? Divide. Good job. You're going to divide by the log of 1.21. So we want to use our calculator. Right, log 20 divided by log 1.21. You're using your log key on the left, so log 20 by 1.
And then years full number?
Well, we gotta make sure it asks you guys in like which year. So let's write this out. 15.7. So x equals 15.7. Right. Now this is 15.7 years since what? 1998. Okay. So let's see. If we took 1988. Thank you. So if we took 1988, and we want to add this. Right. Now, it's going to take 2003, it's going to be the year 2003, and like a little bit more. So, be really careful with this part. Let's go back and see. Find the year in which the number of snowbirds will be 10 million for the first time. 2004, yes, good job. Because think about it, it's like you're saying kind of like 2003 and then like, I don't know, some of the next year. It's actually going to be the year 2004 would be the extra part. So the year would be 2004. That's pretty tough, right?
That was that.
Well, I feel like it's hard to recognize what to do. I'll put another one of those on tomorrow and see if you guys could do it like more by yourself. Because I think that you guys could see that for sure tomorrow. Alright, let's do, since we're on the same kind of track, let's do this next one down here. You guys are pretty good at these. Wednesday. No, today's Wednesday, isn't it?
Today's Wednesday. Yeah, that's why I thought the review class was 12, and it wasn't.
Oh yeah, because you're on Tuesday time too. Yeah. So tomorrow, Thursday, you're in the morning. Holy cow, your Regents is Friday.
Don't say that.
You can stop that.
Maybe we'll save you a spot in your next year.
No, you've been picking up for me. Oh, good. All right, so let's see. They give you a lovely little formula here. Okay, let's sub some things in. What should be your P? 500, because that's what you're starting with. Okay, so start with 500. What is E? E is E, right? Use the button in the calculator. So E is going to say E. How about the rate?
0.0.
Good job, right? Remember, it's the percent, 2 spots on the left. Decimal, good job. 0.05. Do we know what the T is?
No.
No, it asks us how many years will it take for Susie's money to double. So I don't know the T. How much do I want at the end though? Do I know? Very nice, 1,000. They love this kind of stuff. Where is that? How many years does it double? They like doing this kind of stuff, guys. Putting in like for it to triple, for it to double. So you need to think what you invest, actually how much would that be if you doubled it? 1,000. Okay. Now, very similar. Are you guys gonna get like, you're not gonna be able to get bases the same, you're not gonna be able to get anything equal to E. So we have to actually solve this. Right? The exponent is only connected with the E, so let's get that alone first. Anybody know what to do?
Divide by 500.
Good. Divide by 500, perfect. So it's going to give us 2. Okay.
I got to hear that.
Alright, now, how do you guys get rid of the E? We don't want it.
LN.
LN. Good, so you got to take the LN of each side. Because we can't make a 2, like in an E, become the same thing. It's impossible. So we have to use ln on each side to get rid of things. When I take the ln of E, this is going to go to the front.
So does that ln have to stay with the 2?
Yep. What happens with the ln of E?
They curl curl.
Good, that's a done so. Alright, so I need to find ln 2. See what that equals.
Oh, is it?
ln 2. Good. And just be careful you guys don't round this, like keep it in a calculator. If you want to show your work and like write part of it out, that's fine. If you want to.
And divide by 14.
Right, good. 5 by 0.05.
13.
Great. And let's see, I think they have some rounding here. Oh yeah, here's 10th right of a year or something. Good. So 13.9. Awesome.
That's a multiple choice, you can just guess and check.
Right, yeah, you can definitely just guess and check. I've seen that come though on like part 2s, so, you know, anything that's multiple choice, if you...
We'll guess and check if it's... No, you know what I did.
Yeah, but you want to, I mean, you can guess and check with a lot of this stuff, but it could also be on part 2s. Just make sure you know how to do algebra with this too. Alright, good job. Alright, we have some requests for eyes.
Oh boy.
So, this is kind of similar to, you guys had a question, you know, with like X's, Y's, and I's, I think, but this is kind of similar. FOIL, yeah, good job. Alright, so you guys have to do the whole FOIL here because they're not conjugates of each other. So go ahead, FOIL this thing out. If you have trouble with the I's, treat them like an X, which kind of holds the same stuff. Okay. And please be very careful of the last little part. When you do your last, negative what? 3i squared. Good job. Alright, so I squared, yes, and this came up again. I squared is -1. If we can't remember what that is, it's okay, right? In your calculator, if you're not sure how to evaluate them, you have to go to the math key. I part. Go to, yep, NUM. Choice 3i part. And then second period, caret whatever your exponent is. And we get -1. Do you guys all remember to use the calculator? Is that a little pressure? Okay. So if you don't know it, that's okay. Anytime you have higher exponents on the I, you need to reduce them in your calculator. So watch out in here. You have a -3 times a -1. Gonna make this a good. Now you have 8 plus 3 is 11. And then in here, when you guys combine your i's, what's that going to give you?
5 minus 2i. No, I added I subtracted the 8 and 3.
Okay. Make sure you multiply these and get your positive 3.
I got the -2i, that's
Good, good. A plus bi form. Okay, make sure in this part, if you guys see anything like this, you want to make sure the real numbers first, then the thing with the I. So like 11 is the part with the A, -2i is like
So
this.
if this becomes 2i, and like plus 11, so would you have to flip it?
You'd have to flip it, yeah. Yep, so
Would it
that.
stay like that, or would you do like...
So if I had like, let's say, something like -3i plus 5, like that. Okay, you would have,
Like I said, 5 minus 3.
yeah, you'd have to rewrite it like that. Okay. This question didn't ask this, but we haven't done it in a little while, so if you guys had 11 minus 2i and asked you like what quadrant would the graph be? What is it? 11 is like the x. Yep. What's this one like?
-2.
That's like the y. So what you'd really be doing is graphing 11, -2. Good. 11, -2, somewhere like in here. Right. So you just take the numbers and the signs. Right. Okay. Let's do another one. If I gave you guys -2 plus 5i, where would that go?
-2
of
second
5.
Good, -2 of 5, perfect, second quadrant. Easy, but, you know, kind of. Alright, let's see, okay, so, I think you'll get one question dealing with a combination or permutation. You can tell the difference, which one is it gonna be?
I don't think that's it. Oh, yeah.
So in here, there is a huge, key and clue, okay? Anytime you guys are looking to see how many ways people can like come in, you know, or be formed, chosen, come in first, second, third place, or you're either using combinations or permutations. So the idea behind them is if you have a combination, does the order matter? No. So order doesn't matter. Right. If you guys are just like choosing things, you're all going to go to like the same group, no one's getting anything special, it's random, you're using a C. Now with a P though, is, yeah, order is important. Okay. When you guys are dealing with a permutation, you could see things like people in a line, because if you're waiting for your Dunkin', don't you want to be first in the morning?
Mm-hmm.
Yeah.
Probably.
Yeah.
Alright, so first or last is important in the line. If you guys are like running a race, does it matter if you're first, second, or third place?
Yeah.
Yeah, it's totally different stuff. First place is the winner, third isn't. So in here, when they're talking about first, second, third place, what do you guys think? Is that mattering? Yeah, order's important. So we have 8 people. We want to figure out how many ways they can come in first, second, or third. That's 3 ways. Since the order is important, we want to use a permutation. So 8P3. If you had anything with like president, vice president, secretary, that's also another big thing with permutation. The order would be important. Okay. What do you guys think? Good, bad?
Good.
Okay.
Pretty good.
So I'll go, if you guys want to stay, you know, I'll stay for like another 40 minutes or so. If you guys have other types of questions that you want to do, you know, things that keep coming up, I know you want to do some stuff with functions, feel free. Okay. Okay, so here's someone's question. I think you guys will get one thing about either domain or range. Okay, this one's asking you guys to find the range. So what does range mean? X or Y?
Y.
Okay, good. It's got to be the Y. Right away, if you knew that range was Y, which ones can you get rid of in the multiple choice? 1 and 2. See how the X in between? Cannot be those. Okay, they're putting them there to trick you. Alright, domain is the X. So range is the Y. So you want to think on the Y axis, you're looking up and down. So you want the lowest to the highest, and it's got to be using these numbers on the Y-axis. So what's the lowest you guys have hit?
1, 2,
I think this one's low, right? That one's maybe like the lowest.
oh.
Okay, what's the highest? Okay, things aren't exactly great, but hopefully we can kind of tell. All right, so the lowest, is it going to be 1.27 or 0.97, you think? Probably 0.97, because 1.27 has got to be above the 1. So it's got to be.
Jesus.
Okay, does that make sense now? Okay. If it asks you, let's just do a practice one. If they did give you guys the domain of this, right? Domain is like left and right. So which one's the farthest to the left? Which year? 1997. What's the farthest to the right it goes? So if you were going to write this, one way you could do it, I know a lot of you guys like to use the bracket, could do 1997, 2007. Or when you write this, you have to go lowest to highest, 1997, 2007, and which one would you guys need between? X or Y? X, good. Does anybody know why I used greater than or, and less than or equal to? It includes it because you have a closed circle. Somebody asked me that, I think, right? How to write them?
Well, I was just thinking more like the other one, where it was just a big swirl, or like a whole graph, like in all the quadrants.
Okay, let's make one up, I don't know. Okay, so that was that one. Okay, so you want stuff with eyes, right? Okay, here's one. This is eye. Oh, sorry. Alright, let's simplify this. And you can do it like you're looking at it, just a little extra. You can't do that extra. I have to go through that. You guys should be breaking down all of these little I exponents. I don't think your calculators will handle the x, so you have to do each of the. Good, nice Brittany. Okay, you want to do them each individually, so we want to figure out what is I to the fifth. We're going to go to our math button, MUM, choice 3. And you can't do these all together, you need to do them separate because of the x. So this is just I. Alright, so it's just like saying x times I, which is xi. Now the next one, I to the 7th, if you guys broke that down, good job, Brittany. Wait, negative I, right? Negative I, perfect. Okay, so this is going to be plus x times negative I. Okay, so let's watch out for this. X times negative I, well, you have a positive times a negative, so what would this become? Like minus xi. Okay, right, the last one here, what's I cubed? Negative I, okay, so we have x, negative x times a negative I, what's this becoming? Good, positive xi. Great, okay. Now, good, this one's gone, we just get xi. I could definitely see something like that coming up. Something weird. Well, if you have one's positive, one's negative, you're going to do that same thing. Oh, when dividing by 4 and seeing the remainder?
Yeah. With like 100 or 150. But like 45 and all these weird numbers on the side. I failed that test. But
could you have used the calculator?
Yeah, so all in my head.
Oh, geez. Alright, okay, so actually you want the main range, right? Let me see if this is kind of what you're. Oh, this is great because we can do a function too of this. Alright. Keel, you were asking me about a function. Yeah.
Agree. Does not.
Yes. Yeah, perfect. Okay, here we go. Alright, so hated that. Okay, we know this is kind of what you're thinking.
Yeah.
Is that what you're looking at? Okay. Okay, so why don't we find the domain of this and the range? We need to write it correctly.
Yes. Domains X, right?
Goes in like alphabetical order too. I can't remember. It's like X comes before Y, C comes before R.
Okay.
Do we have to stay for 2 hours?
I am, dude, so that's my Twitter.
Usually about, usually about like 2 hours, especially if we have like the little segments and like, you know, or like.
Oh, what's that video, Destiny?
Alright, okay, what do you guys think for, anybody know a domain? -4 to 6, great, okay, so the farthest to the right, farthest to the left on the x-axis. Now, you could write this 2 ways. One way is using your bracket, okay, or you have to put the x between, and would you guys use the equal to, or the just less than, or greater than? The equal to one's good, because right, x is greater than or equal to -4 and less than or equal to -6. If the inequality signs trick you, okay, if you're making them like together like a conjunction idea, they're always chopping to the right. Alright, as long as you have your numbers in order. If you can't remember which way they face, they're always going this way. Chopping to the right. Okay, so let's see, what about the range? What was the lowest number to the highest number? Good job. You have -4 to 3. Super. And then you're going to use your brackets, right? -4 to 3. Or the range -4, 3. You have a y between. Right, and you just fill in. You switch the numbers?
No, like the range and the.
Domain? Yeah. Just remember the axis.
So are they always gonna be facing like the signs are always gonna be facing like that?
Always.
Okay.
Yeah, as long as you put your numbers in order from least to greatest. Ashton, the only thing you think is like,
Yeah, I never got
look at the x-axis. Okay, so look at like these numbers when you're doing domain. That might help you remember like the left and right. I mean, you would get points for it.
Activity makes that little weird smile. You know, like if you turn your head, you know, like type of thing that people like you.
It does kind of.
Know what I'm talking about.
I know what you're
Like
saying.
a laugh.
I have no idea what you're talking about.
But you wouldn't get a switch.
I don't even pay attention.
Wait, did you say it was a?
You know it. I don't know.
No, like you know that little text thing? Like people like actually make the X and the D. So those things all different. Turn your head. Okay, no, I know.
Okay. I get where you're coming from now.
Before you know.
Sorry. That's
I thought you were talking about like the actual like graph.
What?
But I know my ex and my ex so
Oh my god, you still having that? Have you? I was 8 hours.
They do the opposite.
I work like 9 hours.
Okay, what other things you guys got? Anything else that's like? Anything else that you guys
What
need?
did you just say?
Global.
How did it suck?
I passed that by the skin of my teeth.
Wait, you did really? Yo, did it suck, Angie?
No, it's actually the essay shot.
What was that bit about? Yeah, what was it about?
One was the spread of different religions or political ideas,
Oh my god, that is.
and then the other one that you can do was the falls of Roman, Ottoman, and
I'm putting them on the blog.
Okay.
I would have left it there.
the British Empire.
Okay. They're actually good. They're like.
We wrote about Gandhi in the summer.
Yeah, I remember that in summer. That's what everyone
Yeah,
about
like
it.
what I think is gonna show
Thank God we had that.
I'm seeing probably one of the latest that they've done, or the earliest that they've done Regents stuff is Monday through Tuesday.
What other ones you guys want to do? Still pretty shy.
I'm trying to think, hold on.
So do you need more imaginary stuff, or is that still
So next year, do we have any stuff we can take?
Someone, what do you think?
Look at the top.
What do you think?
I
don't have one. I don't think I have. They're probably fun questions, but, yeah, I like the sequence stuff, I'll do that. Speaking of anyone who left yesterday, I would look at the blog section, because we did some tough recursive sequences that, you haven't seen in a while. Was I here?
After I left, Barb?
Oh, yeah. Were we here? You weren't there, you guys all peeked out.
Yeah, I was the only one ever.
Yeah.
Thanks for leaving me, guys.
Yeah, everything held strong.
No, I don't remember.
I had to go.
Oh, I had to go to work.
It's not funny. I didn't take those tomorrow.
That's so bad.
What did you just say?
I was dying. Basketball game,
My physical
Why did you get me down?
because I'm sweating in the basketball game that you're like pumped.
Okay. Why don't you guys try this one? This is a good one. Find the 15th term and sequence. Alright, so first thing, when you guys are doing anything with sequences, you want to identify what's going on in the sequence. I don't know, you gotta decide, are you multiplying or are you adding? Okay, so if you are going and you are multiplying from one term to the next. Alright, so we're multiplying, we need to use the geometric, okay? Multiplication is the geometric, addition is arithmetic. Okay, make sure you guys know the difference and how to tell. So, in here, you're right, we are multiplying. Okay, so we want to use our geometric sequence. One person. Ashlyn, what do you think? You got it. Good job. Perfect. Right, you got to know your formula. Now, with our geometric sequence, we need to fill things in. A sub 1 is always the first term. 5, that's what you're starting with.
5 times -2.
Okay, nice. And what was R? How did you know that?
5 times -2 is -10.
Good. So it's like what you're multiplying by?
Yeah.
Love it. Good. So -2. Perfect. N is what? 15. Good. And it's always the term you're looking for because it's a 15th term. Okay. If it said nth term, and it stays n, but we're going to stuff that in. Okay. Now, when you guys are putting this in, okay, reduce your exponent. 15 minus 1 is 14. Now, please be very careful. What do you need around that -2?
Parentheses.
Good, right. Calculator will mess it up if you don't do it. So, good. Trace? What is it? You guys want to do another one of those?
Yeah.
No, this is
Doing arithmetic.
everyone, which was speaking.
So yesterday there was 80% off.
You know what though? Okay, let's do one of these because it keeps coming up and we keep getting it wrong. So,
Yeah, one of them told me about your phone case you got for $20.
I got a gym. What was it? The gym side? Oh
Okay, this keeps coming up and we keep getting it wrong, so things like this, where they're asking you about the common difference, but it's not just like straight numbers.
I think I'll feel bad. I think I feel really bad. I started doing like I only do multiple choice because I feel hard to start. And then I use some of the ones.
Alright, so see, when you guys are doing it, please be careful, you can only add and subtract like terms. So just look at the stuff with the A's, what's going on in there?
2A.
Good, you're adding 2A to those. What about with the numbers?
Plus 3.
3. Okay.
That was easy.
Alright, good job. Just because, I mean, it's a little, I don't know why, that kind of stuff has been really confusing on people. Sorry about this.
I gotta start working. I'm just gonna
This one? Yeah.
When do we go in?
Why are you invading me?
Probably like next week. Probably like next week.
All right. What's going on with this one? Anybody have an idea of this one?
What do you have? Jump down.
Can
you spell barking order? That's what I'm good at. How about this couch? What the heck?
Why would there be terms coming to?
So, that's each term.
Oh, okay.
I think it's 3. 3.
Oh, 3.
It's arithmetic, so yeah. It's 3, right?
We all get time to look?
Yeah.
I don't know what's happening.
3, you're right.
Yeah.
3.
Yeah.
It's 3. Good. Guys, here's why it can't be 1, okay? You are going up by 4, but we have to add what? 4n here, right? You can't, if you tried to take 4 plus like 8n, those aren't like terms, so you can't even add them, right? This one, you're not adding 4, what are you doing with this one? Multiplying, so multiplying is not arithmetic. This one, you guys would be kind of like multiplying by just one of the terms. That doesn't really make sense. This is the only one you're adding 4, because you would only add 4 to the number, not like the n. That's kind of one of the tricky ones I thought. So just make sure you guys are paying attention to like the like term stuff.
You can't wear that shirt. You dress code. Oh, you dress code. Your shorts are too short.
Oh, this is great. Okay, so let's try.
Yesterday. Was it yesterday? Yeah. You make me laugh raw. She laughs. Some Michigan goes along.
Okay. Alright, let's try this one then. And this will be like our last little. This one.
We can find the nth term.
Yeah.
No, don't got it. Don't got it. He did just get me one.
Well, you're adding the top by 1, it goes to multiplying the bottom by 3.
So we can't like add and then multiply the two.
Well, sure. I don't know.
Oh, I see what you're at. I don't know the answer. Okay. So first thing, and this is where you guys are having a lot of issues.
Oh, no.
how do we, like, it's hard for you guys right now to see what's going on in here, right? A lot of you are deciding, I don't know if it's multiplying or adding, or how do we tell? Any ideas? Yeah, but what form are you going to use?
Geometric.
If you just add it, is it geometric or addition? I don't know. We got to find out. Those of you guys who thought geometric, how can we tell if something's geometric?
Because it's like,
They all have commas.
well,
Idiot. Because, I'm sorry. Multiply? How did you tell? How did you know? Okay, alright, here's, if you guys get stuck and you are not sure what's going on, especially with fractions, it's tough. You can pick one of them and divide by what comes right before. So I take 5 over 64, right, and I divide by 4 over 27. Right? That means that I would have had to multiply by 135 over 256. Now, let's see if that really works for all of them. So, if something's geometric, you have to be able to multiply every single fraction by the same thing. So, if I took my first one, let's say 2, and I times that by 135 over 256. I have 2. The math fraction can reduce that. Wait, do I get then 3 over 8? Alright, I don't think so. I don't think this is going to be geometric here. Let's see. Now, for arithmetic, okay, let's see if we can figure that out. How could you guys figure out what you're adding? What would you have to do between the two terms? Subtract, good. So let's do the same thing, but see if we can figure out the difference. If I took 5 over 64 minus 4 over 27, so 5 4 over 27. Oh gosh, I don't know if this will work either. So we have a minus 121 over 1728. Let's see. So now if we took 3/8 and we add that amount, let's see if we'll get the other answer.
can you write?
No. Does that not work too? I just want you guys to randomly do this. Oh, it doesn't work either. Okay. Is this random? What the hell? This just topic.
My laptop.
So this is an arithmetic or geometric. They want you guys to do a sequence. They're not going to have you guys do this. It's not from Regents, from Jana. Alright, so if you had something like this, what do you think?
It goes 1, 2, 3, 4, 5, 6.
Well, on the bottom, if you guys look at what's going on in here, they're all squares, cube, yeah, cube. So, do you guys see this is like 1 cube, 2 cubes, 3 cubes, 4 cubes, 5 cubes? What would 3 cubes be?
Yeah, right.
This is weird. They usually never.
Oh, that's right. Look at that. We're at the top.
So 216. So it has to be these. 1, 2, 3, 4, 5, 6. Yeah. Holy cow. That's like that way they already love our math. That's good. I know. I thought you have to do arithmetic or geometric. I didn't think that you could just like, it was going to be like a straight, like, what's the average? But, yeah, you were like, strange. Alright, well.
Wait, so how'd you get that?
So arithmetic and geometric didn't work. Like, it wasn't doing the same thing. So, if you look at the bottom, Donovan noticed that they are all perfect cubes.
Yeah.
Right? So 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. Next one would be 6 cubed, which is 216 on the bottom.
Oh, alright.
When you look at it that way, it's easy, but like when trying to figure out what was going on, you can't. Good job, Donovan. Perfect. All right. So, how are we with sigma?
Oh,
You need help with sigma?
yeah.
I wanna do a tougher one.
I really think it brings it out of square root.
Yeah, I don't know if you'll have to do a writing one.
That one's not Regents here.
One of the Regents.
Yeah, we need to like check it.
Oh, like when you do each of them out?
Yeah.
Oh, here, alright, now let's do it again.
Maybe like what's the 43rd term or something.
Alright, you know what, we'll do two of these, it's like a fine one. Alright, let's do something like. Oh, the one in your jury, didn't you have an X in it too or something crazy?
And I think a lot of people got it wrong because.
Do you have the Regents with you?
Yeah.
Okay, let's try this one first. I want to show you a shortcut in your calculator, and then we'll do that one. Alright, what are we starting with? When are we starting with? Plug in. 1, good, okay. Let's start with 1, so we see name, put a 1 in, we got 1 plus 1 all squared. What operations go in between? Plus, good. Alright, so we're going from 1 to 4.
You have to multiply it by 2/3. Okay,
Yep.
good, because this is, the one, last time I got this, I did it all by 2/3.
Wait, I thought you were gonna like add 2/3, not multiply.
If there's a plus between you, then you would.
Okay.
But
otherwise, just multiply it?
yeah, if it's smushed, because it's grouped by multiplication, not addition.
Okay.
So now we have to do, we're going from 1 to 4, so we gotta do 2 plus 1 squared plus 3 plus 1 squared plus 4 plus 1 all squared. Would I do 5 plus 1? No, okay, we want to stop it at 4. Okay, so do each of these out, and at the end we'll deal with that one, the 2/3. So this is going to give you guys, make sure we do PEMDAS. 2 squared is 4. This is going to give you, good, 16. What's the last one going to give you? 55. Perfect. All right, so let's add these all together. What'd you get? 54. Can you see that? Okay, so now at the end, make sure you guys are doing these at the end. Times it by 2/3. And what would you get? Good job. Alright, now the one that you guys are talking about with your. Oh, I know what you're talking about. Okay, yeah, that's no problem. You guys just do them all out. Alright, so the other way you guys could see this is like kind of like using it as a guess and check. Nope. That's why I was just saying. Yeah, this is what I want. Okay. Let's do this first one again. Okay. So this kind of is what you're talking about, Cam, with yours. I think something like this, right? Alright, so here, they want to know which one identifies this series. They want you to use the multiple choice and go back through. So, you want the multiple choice to kind of like help you here. So you want to start with 1 and you want to go up to 6. So if we do 1 in here, 8 times 1 plus 1, what would that give you? 9, good. So 9 is your first thing, this is looking good. So now if we went from 1 to 6, the next thing we would need to plug in is a 2. So if I do 8 times 2 plus 1, we get 16 plus 1 is? 17, alright. I mean, I would do a couple. Okay, so if we did 8 times 3 plus 1, we get 25. Okay, now don't stop once you get the first like 3 to work. What did I tell you guys you have to end with? Doing, so you make sure you get the right one. 6, good. If you put 6 in here, we want to get 49. So 8 times 6 plus 1 is 49. Oh, no, this is it.
Yeah.
Sorry. If you tried to do all of them, like, that was kind of stinky. I wanted to show you what. So if you tried to do more, so here, you did 8 times 2 is 16, minus 7 is going to give you 9, but then if you did like 3, 8 times 3 is 24, minus 7 is, that works. Oh, and then if you did 8 times 6 is 48 minus 7, would that give you 49? So you want to do like the first like 3, then make sure you end with the top. Because a lot of times they'll start it with like the first 3 being okay, but when you put the top number in, it fits it.
So I think it was the one, the cast was, like, the other side net, but it had 43 like over the.
So that means if you put 43 in, you want to get the last number
So I
out.
just meant like.
That was the last number? Yeah. So you want to use multiple choice like small. That means you could have used it. Okay, good. Alright, I got time for like one more. You guys think?
Can't you just do all that on your calculator?
No.
You literally just type.
Well, I mean, like the math part, like this?
Yes.
Yeah, I mean the subbing? Yeah, you
No,
can.
just you just plug the whole sigma in.
The only thing, if you did the whole sigma, it's gonna give you what this is all added up. It's not gonna give you each term, but you could do it that way.
I think you should just add it up and figure.
What about though, you know, sometimes they have like, they have things where there's, things are 1 and dot, dot, dot,
Got it.
then you
Okay.
can't. So, let's actually go back to the last one and make sure. So if you guys did get something like this though, in your calculators, there's a way to make sure you get this question right. Okay, let's just go through real quick and make sure you know how to type it in. Do you guys remember how to get the sigma? Alpha window. Thanks, Katie. Just put it right back there. Okay, so alpha window. Good. All right, you want to go to choice 2 where it says your little sigma. Now, I don't know if we can draw in the front here. Can I do something together? Oops, no, I can't. All right, so let's type in what we have, and then at the end we'll multiply by 2/3. So, your calculator. I mean, A is like an X here, it's like a letter. I don't have a lot, but I don't think I would use them. If you want to keep them with whatever you guys have.
Which
one? Oh, okay.
Oh, no, I thought you meant.
Oh, no. I we put them all together one year in that crate thing, and then, sorry. If you want these, you could totally have them. Let's see, so if we do X instead of like the A.
I did not get one of that.
Okay, put your little 1 in here. And then, let's see, we wanted to go up to 4. And then we want to put in your equation part. So we have x plus 1 all squared. So let's see. So x plus 1 all squared. Okay, so let's see what this is going to give us. Oh boy.
Yeah.
Yeah, but hang on, I didn't actually do this. Times 2/3.
Yeah, it's only 30.
So 392 over 3. Hang on, let's go back to this. Oh,
Yeah, that's what I got. I didn't get that. Is your X something? Oh,
this
yeah,
is right. 54 is right?
my X is like 6.152 something. X isn't 0 in mine. Is your X something?
Like, did I store it as something?
Yes, it could be.
I don't think so.
I don't know.
You got the same thing?
Yeah, I got one.
This is right? This is, yeah.
Yeah, that
One, 25, yeah, good. One start. Got 4 right. Hang on, let's see if this makes it up right.
no.
What do you use that for? Did that work, Donovan? You got 20? Huh, alright, well, you know what then, I don't know why this is not working. The mode shouldn't mess it up though, is it?
I'm getting the same thing.
You're doing the same thing. I don't know.
Did anybody get it right?
I don't know why it's not working on this.
Think it's just a problem?
But I did do it.
Yeah, maybe it's
No,
just
'cause
on
we've
this.
done problems with 36.
What do you have to do?
You can't touch the parentheses area here. Like what you did,
Okay, help me, what did you do?
Yeah,
when the parentheses are there, you put the statement in, you can't touch them. So you have to put another statement inside.
Alpha, window.
what do you mean, like parentheses and parentheses?
Yeah.
Alpha window, okay. Choice 2. Did you put, you got F, you got your 1 in, like this stuff? Or 1. Okay, so what did you do over here?
Another parenthesis.
Another one? Okay, and then do X plus 1. What was it? Square? Ah. Tricky, Donovan, thank you. Then we can take that and times it by 2/3. So it goes to show you, let's make sure we go both ways, right?
The boards are losing your edge.
I know, totally losing it. All right, I'll put this up on the blog so if you guys have friends that did show